Going to talk about this assignment, which is about recursion. Basically, you're asked to write a Java program to use recursion to solve a math puzzle. The math puzzle looks like this. Imagine you have um, the sum of a 3-digit integer and a 4-digit integer and a third integer with 4 digits, and you know the sum of these four would be a 5-digit integer. Also, what's given is each of these letters like T, H, E, B, P, O, S, all of these representing digits. For example, T can be a digit from 0 to 9. H is another digit from 0 to 9. So these are given in the puzzle. Remember, if the letter O is 5 here, it should be 5 here as well. Or for example, if the letter T is 7 here, it should be 7 here, it should be 7 here, it should be 7 here. So we know some of the digits of these numbers are repeating, and basically we are going to find out all the solutions of this puzzle. In order to do that, there are many ways. We are going to use recursion here because recursion is very good at finding a specific value in a very large search area. So because let's say you have, in this case, 7, 8 different variables, and each variable can be a digit from 0 to 9. There would be millions of different possibilities or different combinations. And out of those million combinations, probably 1 or 2 of them will make this summation correct, right? Or will be satisfying this puzzle, which basically means the sum of these 3 should be equal to the result that you see. V is the first one, best is the second one, spot is the third one, and the last one is the spot. So in order to find out one combination out of millions of different combinations, we are going to use recursion, and I'm going to show you how it's possible. So you need to basically solve the puzzle using a method like this, and the way the puzzle is passed to the program would be a plain text, which I'm going to show you later, but you're going to store all the characters or all the variables in an array list of characters that, for example, for this example of D best spot equal spots, the variables would be these. As I said, we have 7 variables here, T, H, E, B, S, P, O. Every character would be a placeholder for a digit from 0 to 9. And this solved puzzle would be recursive. That's one thing that you need to always remember. You cannot solve this without recursion. You must use recursion to solve it because, you know, we are trying to learn how recursion works. And one thing you notice here is this array of digit values. This is basically an array of integers that maps the characters to digits from 0 to 9. And that's going to be like one possible mapping of these characters that you see here, these 7 characters, to the digits that we have from 0 to 9. So the digit values is an array of this size 256, because we know for sure that the ASCII codes of characters that we have in the alphabet do not exceed 256. So that's why we use this specific number. As you may know, every character in alphabet in Java is represented with an ASCII code, and that ASCII code is a number. For example, letter T is represented by ASCII code of 84, or letter A is represented by ASCII code of 65, and so on and so forth. Letter Z is 90, for example. All right, and basically, this digit values can map a letter to a number or a digit using this. You can say digit value of T equal 5. That means from now on, I assume that T represents digit 5, right? So using this digit values array, you can map any character in the alphabet to any digit from 0 to 9. And this is how we can store a possibility or a combination of values for our variables, right? And this solve method basically has to check whether, any of these combinations satisfy our puzzle, which is basically D plus best plus a spot should be equal to spots. So remember all of that. Because solve is a recursive method, it has to have a base case. And I'm going to tell you what a base case should look like. I'm going to show you a similar example to just show you basically what a base case looks like. But let's do it this way. Let's assume that you're trying to implement this method and find all the combinations of, or all the mappings of characters to digits so that it can solve our puzzle. In order to find all combinations, you need to assume that digit values are initially mapping the characters or the variables to -1. -1 is an invalid digit. We don't have a negative digit. So that's why I use -1. And originally, when you map a character or a variable to -1, that basically means you are not assigning that variable to any digit yet, but you are going to assign it to a digit in the future. When I say in the future, I mean in the future calls to the recursive method solve. And that's a sign of an incomplete assignment. If any of the variables participating in your puzzle is pointing to -1, that means your mapping is incomplete and it's going to become complete in the future calls to the solve method. So that's why initially all the variables are set to -1, but we gradually assign each one of them to a valid digit from 0 to 9. And the base case condition of this recursive method can be set to when no unassigned variable we have. That means none of the puzzle variables are mapped to -1. If that happens, that means, we are done. We have mapped the characters or the variables, the 7 variables we have here, as I showed you here, to digits from 0 to 9, and then either that combination solve the puzzle or it doesn't solve the puzzle. If it solves the puzzle, then congratulations, you solved the problem, or you found one new solution to the problem or to the puzzle. If not, then not a big deal. We're gonna continue and check other combinations. So this is how things look like. Now, let's get into the more details of how to find the list of variables, and then how to evaluate the value of a number with multiple digits using the mappings that we created earlier. Let's start with how to find the list of variables. Imagine the user uses keyboard to enter a string puzzle. That string puzzle would be basically is a single line that says, for example, D plus best plus spot equal spots, if you want to solve the puzzle I showed you earlier. Now, we need to find out all the variables, which is participating letters in that puzzle, and store it in a list of characters. I'm gonna show you a starter code where I have a static array list of characters that is only defined for this purpose, to store the characters involved in a given puzzle by the user. And that array list is going to be filled up with this method, find all variables, which is again given, you can use it. You basically pass the string representing the puzzle to this method. This method is initially clearing the whole array list of characters. We call it variables. And then it goes through every character of the given puzzle. As long as the character is a letter and it's not already in the array list of variables, it's going to add it. Why do we need to check if it's a letter? Because in the puzzle, you may have the signs like plus or equal sign, which are basically the assignments or the equation, or the operators like plus, and we don't want to deal with them, right? We don't want to consider them as variables. It should be a letter. It should be a letter in the alphabet, and it cannot be repeated. So if you already have a letter T in the array of variables, you should not include it. But if it's not in the variables list, then add it for the first time using this statement. You all know what array list is, and contains method searches for a value in an array list, and add is going to add a value to the end of an array list. You all know all of that. So this is not a new thing for you. Now, the other question is, how can I convert a string like the or best or spot or even spots to the integers that basically have a numerical value? Imagine, for example, T is mapped to 1, H is mapped to 2, E is mapped to 3. If you consider this mapping, let me see if I can annotate this. So let's say T is 1, H is 2, and E is 3. If that's the case, then your THE represent the number 123. Again, if T is 1, E is 3, and let's say B is 5 and S is 7, so the best would represent 5,371. Again, if the S is 7, T is 1, O is, let's say O is 2, and P is 9, so a spot would be 7,921. And then the spots would be 79,217, right? So I want to basically find out the numerical value of each of these, assuming that you have some sort of mapping between the characters and the numbers. How can I do that? This is a function designed for this exact purpose, or the method. The method basically called numeric value. This method basically gets two parameters. One is the word itself that you want to find its numerical value, and second one is a mapping between characters to digits. So this mapping is the same one that we passed to the solve method, remember? And we said if the content of this is -1, that means the corresponding character has no assigned values. But we always call this method when we have successfully assigned every character participating in our puzzle to a digit. So none of the important characters, or none of the participating characters, are mapped to -1 in this array. So these are all valid digits that we have mapped them to the variables. What you need to do here is go through this for loop and go over every single character of the word and check out the mapping between that character and a digit. If the mapping is less than 0, that means C is not assigned to any value yet. That's a bad news because it shouldn't be the case. We're going to return -1. We assume that every character is mapped to a digit when you call this. So that would return -1. That means something went wrong. But otherwise, we are going to use that, use the value assigned to that character to make the number. So let's see a quick example. Imagine the same thing. Let's say the word is THE and the mapping maps T to 1, T is mapped to 1, H is mapped to 2, and E is mapped to 3. So imagine that, right? The first iteration of this for loop, C would be, the character C would be T, and then the second iteration, it would be H, and the third iteration, it would be E, right? So first T, then H, then E. In the first iteration, when RV is initialized to 0, by doing this assignment, RV becomes 10 times the previous RV, which is 0, plus the value of letter T, which is going to be 1. So by the end of the first iteration, RV should be equal to 1. In the second iteration, when character C is the second character, which is H, then RV should be equal to 10 times RV plus the digit value of H. So RV is 10 times 1, which is equal to 10, plus the value of H, which is 2. 10 plus 2 is 12. So that's the second iteration. In the third iteration, now that RV is 12 and the third character is E, we have to evaluate this statement in the following way. RV should be equal to 10 times the current value of RV, which we said last time it was 12. And then we add this by 3. So it's going to give us 123. And this is basically correct because if T, H, and E are 1, 2, 3, THE or the word D, THE would be 123. So this method is doing its job properly. When it returns -1, that means you have an unassigned character. There's a character that is not assigned to a digit value yet. So you need to take care of that error somehow. You made some mistake in your code. All right. How does the input output the program looks like? The input looks like this for the example that I showed you. Basically, D plus best plus a spot equal spots. And you need to basically break down this in your program into the words D, best, and a spot that are added together to create the word spots. And when you solve that puzzle, you get a solution like this. Let's figure out whether this is the correct solution or not. If the mapping that you see here is correct, then that means the word D is 943 because T is 9, H is 4, and E is 3. Best is going to be 8,319 because, S is, I'm sorry, best, B is 8, E is 3, S is 1, and T is 9. So that's the best. A spot would be 1,029. And then when you add these with a calculator, you will get to 10,291. And if you use this mapping to find out the numerical value of a spots, you will get to the same exact number because, S is 1, P is 0, O is 2, and T is 9. So that would give you 10,291. And that means you found the puzzle. You found the solution of the puzzle. This solution is one mapping from all the mappings of all these variables, all these 7 variables, to the digits. As I told you, there are 10 million, as I said, millions. There are 10 million different mappings of these variables to the digits. There are 10 million different combinations. Out of those 10 million, only this one can solve the puzzle the way we want it, right? Also, assuming that the numbers can have leading zeros, if you, let's say, for example, THE is not really a 3-digit number because T is 0, that means you have a leading zero somewhere. Then if you assume that the leading zeros are also valid solutions, then your set of all solutions will expand and you will have a list of solutions as long as these. All of these would be correct, but as you see in all of them, there is a leading zero. S is 0. S was a leading character or leading digit of a spot or a spots. So these are all 0. S is 0 here, except for the last one. The last one is the one that I showed you earlier. The last one is this one. This one is the same as what I showed you earlier. So only one of these have no leading zero. Now, you need to write the code, which I'm going to show you a starter code. That's basically done lots of the steps, and you don't need to be worried about some steps that are not related to recursion. So most of the code is done, but you need to do the recursion part. And you need to find a solution. If you find all the solutions, you get 100% of the credit. If you can successfully exclude the mappings that map multiple letters to the same digit, then you will get an extra 10% credit. What do I mean by excluding mappings that map multiple letters to the same digit? Let me show you an example. Let's say I'm trying to find one example here. It's better to just give you an example from myself. Let's say if you have like letter T and E, for example, each are mapped to the same letter 5, then that solution is invalid because we assume that every letter should be unique, right? So if you can exclude those solutions, then you will get 10% extra credit. And also, if you can exclude the solutions with leading zeros, that means, no word should start with a 0. So, for example, all of these solutions should be excluded because they all have an S equal to 0 and they should not be part of your solution list. If you can exclude them successfully, then you will receive another 10% and your total credit would be 120%. And that's going to help you get a better grade at the end. So remember all of that. That's the grading criteria. And then if you want to do the extra credit, you need to have a README file. Write the README file and clearly state that your code contains any of these extra credits. You say, okay, I did the extra credit of removing leading zeros, or I did the extra credit of having distinct mapping between characters and digits, and there is no 2 letters that are mapped to the same character, same digit in my solution. If you do one of those, just include it in your README file, claim it, and I'm gonna check if your claim is correct. If that's correct, then you get the extra credit. And that's pretty much it. You get up to 120 points. And that's it. Now let's go through the code. I'm gonna show you the code, and that's gonna be useful for your other assignment I gave you. That was a discussion, I guess. So that was discussion, the last discussion. So I'm going to go through this code. This is the code that is written for a similar purpose. I already explained what the program wants you to do. We want to solve a puzzle. So I call that class alphabet sum puzzle. And in the puzzle, I have 2 private static array lists. The first one is array list of characters called variables. That would be a new array list. Initially, it's empty, but we're gonna fill it up with whatever the user decides to enter in their puzzle. And then I have another array list called operands. This is an array list of strings. That would be all the sum operands given by the keyboard. For example, in the given puzzle, the best and spot are the three operands. And then I have another private string variable, private static variable called result. And this one is set to null, but it's gonna be eventually be equal to the word spots if you wanna give that same puzzle, right? So basically the operands are in this array list. The result of the summation would be in this array, this string, right? Very straightforward. Why do I define them all outside? Because I want all the methods can have access to it. I could have defined them as local variables of main, but this way everyone can have access to it and it's gonna be much easier. Now, this is the main method. You're gonna start with creating a scanner on the keyboard, and then as long as the keyboard has next line, you're gonna grab one puzzle from the keyboard and then tokenize that puzzle, or I should say split it using non-alphabetical letters. This means non-alphabetical letters. Anything but A to Z, A to Z. That's going to break it down into different tokens, different words. So the first token would be D, the second token would be best, the third token would be a spot, the last token would be spots if your puzzle is the best spot equal spots, right? This is gonna become D as the first one, best as the second one, spot as the third one, and spots as the last one. So that's gonna tokenize your inputs, and then in this for loop, I will go over every single token and basically add it to the list of operands, except for the last token. The last token is not gonna be an operand. This is gonna be my result, right? So by going through this for loop, I will basically add my first three tokens to the operands. So the operands will look like this. I have a D, I have best, and I have a spot, right? And then you would say result is equal to this. That means, basically my result would be the word spots, right? Assuming that this is the input. Then I will create this mapping, as I told you. It's an array of 256 integers, and they're all set to -1 in this for loop. You just initialize them to -1. -1 means I have not yet assigned this digit to any values, but I'm about to do that when I'm solving all the when I'm solving the puzzle and finding out all the combinations of mapping variables to values. So the next method is find all variables, which I showed you earlier. Let me quickly show it to you here. Goes through, initialize or clears the variable, because you may call this method multiple times for multiple puzzles. So every time you need to clear out your array list and then go through this for loop. Go over every character of your puzzle. If it's not a letter, then ignore it. But if it is a letter and it hasn't been added to the list of variables, then add it. That's very straightforward. After doing that, then I'm gonna call print all combinations. That was just to show you an example that I asked you to do for the last discussion. But this is nothing but printing all combinations using recursion, right? When I say all combinations, I mean all possible mappings of characters that we have in the puzzle to the digits that we have. So for the big example I showed you, this will print 10 million different possibilities, which is insane, right? But for example, if you're passing a small line like AB, letter AB, then it's gonna print 100 characters. So, I'm sorry, it's gonna print 100 combinations. Let me show you a simple example. The print combinations should print all the mappings possible between characters and digits. Let me run it to show you. Give me a second. For example, if I say letter A, it says A is mapped to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? If I say letter B, same thing. If I say letter C, same thing. But if I say AB, if I have like 2 digits, 2 characters, it's gonna give me all the combinations. Actually, it didn't. Give me 1 second. I have to fix that code. I made a mistake somewhere in this code. I need to set the digit values, assign value to -1. Let's run it again. I'm sorry. I thought it's working. All right, so let's do it again. I'll explain the rest of it, but I haven't explained anything yet. I'm just gonna try it once. Okay, so A is this. If I say A, B, now it's doing the right job, which is basically go over all the combinations. We have 100 combinations, 0, 0, 0, 1, 0, 2, all the way to 0, 9. And then it's going to show you all the combinations of mapping A and B to A to 1 and B to all the character digits from 0 to 9. Then A would be 2, B would be digits from 0 to 9. Then A would be 3, B would be from 0 to 9. So it shows all the possibilities of mapping A and B to digits from 0 to 9. There would be 100 possibilities because there are 100 possible, I'm sorry, there are 10 possible combination, 10 possible mapping of A to digits, 10 possible mappings of B to digits. 10 times 10 is the total number of combinations will be 100. And if I say, for example, TFG, there would be 1,000 different combinations. You can check it out yourself. There are, I mean, you can go through all the 1,000 lines that are printed and check out. There is no missing mapping or missing combination. Everything is printed. Now, how does my program print them? All of it happens in this method that I showed you, this print all combinations. Let me go over the print all combinations. This is a recursive method. So recursive methods can do crazy things, like in this case, they can go through all the possible combinations and then print all of them for you. How do I do that? First thing is this. I get an array of digit values. As I told you, this is gonna specify which digit I'm mapping every character to. Initially, the digit values are all -1. That means there is no assigned value for for each of my characters. The first thing I need to do in the print all combinations is that I have to check if my mapping is complete. Let's create a Boolean completed to true. Create an unassigned variable character, which is initialized to 0, but I'm going to fill it up later. Then I'm going to go through all the variables that I have. This is basically the list of all variables that is entered by the user. I'm going to go over this array list, and I'm going to check the mapping of that variable to a digit. If the digit values variable is -1, that means the variable hasn't been assigned to any value yet, right? And that's basically what I need to do after that. You need to say the assignment is not complete because I found one variable that is not mapped. And this is the variable without assignment is stored in the unassigned variable because I'm going to assign it to a character later or to a digit later. And I'm going to break out of this for loop. When I break out of this for loop, I check out the complete Boolean or flag. If it's complete, if I find no digit like this, then it's the base case. You can go ahead and print all the mappings between variables and their digit values. For example, you can say T is 0, H is 6, E is 0. Like one line of that crazy long output. And then you print a new line after you print all the mappings of those variables to the values. And that would be one line of the output. That happens in the base case. But if the complete is false, we get to the recursive step. So in every call to this method, we either have a base case or we have a recursive case. In the recursive step, this is what I need to do. I need to go over all the possible values that I can assign to the unassigned variable, which is digits from 0 to 9. And I'm going to set the digit value of unassigned variable to I. What is I? I is one of the digits, right? So basically, assign the unassigned variable to one of the possible digits, which is 0, 1, all the way to 9, right? And after you do that, then you call them print all combinations again. This is the recursive call. That's why we call it recursive method, because this is the recursive call. And this is gonna start over again and do this again and again and again and again until they all finish in the base case. If after you take care of this for loop and assign the unassigned variable to all the digits from 0 to 9, then you again assign it to -1, right? So at the end, assign the unassigned variable to -1 again, so that it later gets different values for other combinations, right? So after you set it to value from 0 to 9, you unassign it again so that later it can get different assignments for other combinations of other variables. So this is how your recursive step looks like. This is all the combination. This is the answer to the discussion that I posted. Now, how can you change this to solve this problem? You need to use the method that I gave you, which is the numerical values method. I have showed you, I have placed two different solutions. I'm gonna delete the slower solution. You don't need to see this solution. It's already on Canvas, but you don't need to see it. I'm gonna show you this. I have already shown you this fast implementation of this method, numerical value. The numerical value method basically gets the string, gets all the mappings, and returns the numerical value of this string word. All right, let's see a demo of that. Let's say, for example, the digit values of T, H, and E are set to 1, 2, and 3. Then you can print out the numerical value of THE using this call, and the return value, as you see on the very end, would be 123, right? So that's basically how the output looks like. One more thing I need to tell you about this is how to change this method to solve the puzzle. In the base case, you need to make some changes. Instead of printing every combination, you should not print all combinations. Print a combination or print a mapping. You should not print all the mappings. You should print a mapping only if it satisfies the puzzle. What does the puzzle say? The puzzle says, for example, the best spot equals spots, right? So what you need to do is first calculate the left-hand side of the equation. Then calculate the right-hand side of the equation. Then proceed with the following code. Only if the left-hand side is equal to the right-hand side. If it's not equal, don't print it because that would then be a valid solution, right? For extra credits, you should also consider more conditions before moving forward with printing the solution, right? So if you want to get extra credit, for example, if you don't want to get extra leading zeros in the variables, before printing these, you got to make sure that no initial letters are assigned to 0, right? Or if you want to get the extra credit of having a unique mapping, you need to make sure that no two characters are mapped to the same value if you want to get those extra credit. But basically everything happens right here. So how do you, let me give you an example. Like how do you calculate the right-hand side? The right-hand side is always a single word. So all you would say would be this. In right-hand side, or yeah, let's call it right-hand side. That would be equal to numerical value of the string results. Remember what result was? Result was basically this, which we initialized it here. So you got to get the numerical value of result with the given digit values. And then to calculate the left-hand side, you need to go through this for loop. You need to say for every string operand in the list of operands that we have, make your left-hand side initialize to 0. And then you would say, let's add this by the next operand, which is numerical value of each operand and the digit values. And that's pretty much it. That's how you get the left-hand side and the right-hand side. If they are equal, then you're going to proceed with these. If they're not equal, then don't print them, because guess what? If you don't, if you print everything, then it's going to print all the combinations without any check to see if any of them will solve the puzzle, right? So, for example, let me run it again. Let's say I haven't done those checks, but I just showed you how to do it. But let's say if you just say the best spot equals spots, it's gonna print you all the 10 million different lines, and this is like ridiculous. You don't want to print all the possible combinations. You only want to print some of them which solve your puzzle. By checking the left and right hand side to be equal, then you need to go ahead and solve, print that, right? This is so long that, even if I don't stop it, it's not going to get to the end of it. So I'm going to stop it manually. So that's pretty much it. Thank you for listening and have a great day. Bye.